Okay, so let me recap this once again. We discussed that. Let me also rename this as data science using R. We discussed about the various data types. We started off by discussing about continuous data and discrete data. Continuous data is that data which can be represented in decimal format and it makes sense. Discrete data is that data which is represented in decimal format if represented in decimal format does not make sense. And we also have nominal data, ordinal data, interval data, and ratio data. People who have missed these, how do you watch? One is we have already placed the link on the sticky note, or you can go to 360 DigitMG website and click on the YouTube link here. Okay, we have the YouTube channel. You need to just click on that. And then here, yep. So you can just subscribe to the channel. This is the video that you might want to watch. This is the first day video, friends. Okay, you can watch this if you have missed out of that, and also subscribe so that you get to see the future videos also. This part is clarified. And I've also told that lucky draw will happen from tomorrow onwards. Now, we discussed about the data types. If you do not remember any of these, watch the video. We also have exploratory data analysis or descriptive statistics, within which the first step is finding the first moment business decision. This is also called as measures of central tendency. And we have three measures of central tendency: mean, median, and mode. Mean is also called as average. And when you have outliers or extreme values, then your mean gets influenced by that. Mean changes significantly. To fix that problem, we have median. Median is the middle value of a data set. Any middle value of a data set is called as median. And median does not get influenced by outliers. Okay, median does not get influenced by outliers. Then you have mode. We calculate mode when we have categorical data. These are a few things which we discussed. Then we started discussing about secondary moment business decision, in which we discussed about measures of dispersion. We have three measures of dispersion: variance, standard deviation, and range. We'll learn about all three of these in further detail. In the interim, we have also discussed about inferential statistics. Inferential statistics means if you are given a population, we cannot go after the entire population. So what we do is we come up with a sampling frame. And from the sampling frame, we apply a technique called as simple random sampling to get a sample. Simple random sampling is a blindfolded technique. It is the best technique, and it is also blindfolded, meaning you just close your eyes and pick up a few numbers. That's it, right? You just close your eyes and pick up a few. That's called as blindfolded technique. This is one of the best techniques. Though you work on a sample, you make statements about population. Hence, it is called as inferential statistics. These are a few things that we discuss. Now, what I'm going to do is I will go to website. I will say download R. People who are using Windows, you just say download R. You can also say download R for Windows. The moment you say that, the first link that you get, download R for Windows, you just click on that, and there is an option here which says install R for the first time. Just click on that. And then here you see download R for Windows. Click on that, and it is going to download R for you. Let me click. It's downloading here. Okay. After I download and install this software, I'm going to download and install another software. But let me click that. I need not install it again because it's already there on my machine. Just to ensure that you all understand on how to install, I've downloaded the file. Then click on this. It would open an installation file for you. Click on yes. Click on OK. And do not change any settings whatsoever. Just click on next, next. Right? It's already there, but okay. For me, it is already there. For people for whom the software is not there, you just click on next, 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 job done. Okay, and then it will install R for you. Let me open this file after the installation, and I'm going to run a few basic functions on this. Very basic functions. Finish. And you can actually open that. I would say R, or let me go to start. Let me see, where is R? Here we go. Yep, here it is. So I have R. You have two softwares. One is for a 64-bit machine. Another is for a 32-bit machine. Which machine are you running? You just go there, say, am I running 64-bit machine or 32-bit machine? And then you read this. You'll come to know on whether you're running a 64-bit machine or a 32-bit machine. Follow those instructions. If you are running, usually the new laptops are all 64-bit. If you have very old laptop, that might be on 32-bit. If you have 32-bit, click on this. If you have 64-bit, click on this. There we go. I'll maximize it. This is how the tool would look like. Let me try to zoom if I can. I don't know whether I can. This is not letting me. That's okay. So what we have to do now is, if I want to use this R as a software and as a calculator, I just do 1 plus 1, 1 plus 1, and click on enter. You press on 1 plus 1 and click on enter, you get a 2. If I say 5 multiplied by 8, 5 multiplied by 8, enter, it's 40. So you can use this R as a calculator also. But this look and feel is not good. It's very small, probably not visible to you all, right? You all have such issues. Hence, what I would do is, there is another software called as R Studio. So you download R Studio. Just click on that. R Studio you cannot install that as a standalone application. You need to first install R, and only then you can install RStudio. Both R and RStudio are free if you want to use for your own purpose. For your practice, if you want to use, both R and RStudio comes for free. So here I'm just going to this free option of RStudio. I'll click on download, and I have the installation file here. Just click on that. It would download the file for you. Once you download the file, you'll have to install this also. And one more thing, friends, you can download and install R as well as RStudio on Windows, Macintosh, Linux, on all the flavors. Absolutely, right? So RStudio, both of these are operating system agnostic, meaning you can install on any operating system. I'll click on RStudio. Yep, I will click on yes. I want to install that. Then there will be a pop-up window now. I just need to click on next, next, next. That's it. I am absolutely not concerned about any other option there. Next, 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 job done. Okay, it is extracting all the required files and then it is trying to install. Okay, so we'll wait for this installation to complete. Done. So I'll click on finish now. Now what I would do is I would open the software, RStudio. You can also search there, but I'll just scroll here. You have RStudio. I'll click on that. Clicking on this would launch the application. Okay, I don't want all these. When you open RStudio for the first time, this is how it would appear. This is how it would appear. So all I want to do is say type 1 plus 1, enter. I got 2. If I say 5 multiplied by 8, enter, I get 40. What this means is you can use R as a calculator also. Okay. Now I'll do this. I'll do a drop down here. Everyone, please observe. You have a drop down. Just click on the drop down and click on R script. If you do a drop down and click on R script, it would open a script window for you in this way. It would open a script window. You need to write your functions in this. You need to type your functions here. For example, I'll just clear the screen. If I type 1 plus 1, if I were to run this line, I can place the mouse cursor anywhere on this line, at the start or at the end or anywhere in between, and just click on run. There we go. The answer is 2. And if I type 5 multiplied by 8, click on run, you get 40. It is this simple, friends. It is this simple. Now, a few more things that I wish to tell you guys is when you want to import a file, when you want to import a file into R, I mean, you can import all sorts of files into R in the first place. Then you just need to do a drop down, import dataset. And when you do a drop down, you see two things, base, readr, etc. Okay, let me write on the screen. It's, I think, some kind of a pen that I have. Sorry, let me open that pen. I just forgot the name of that. Because I need to scribble on the screen. I need to write something on the screen. So let me choose this pen. Where did that go? Pen. I need that pen, otherwise it will make my life very difficult. Where did that go? I just forgot the name of the pen. Just give me a minute while I try to load that. It's not appearing here. Let me see. Uh, 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 Not visible. Uh, just give me a minute, friends. Let me quickly check one more time on where I have placed that pen, or I will download from the internet. It just takes a minute for downloading that. Oh, Wacom. Do they give anything? No. Okay, fine. I think I need to download that particular software. Just give me a minute. Screenwriter pen for Windows. Epic Pen. I just forgot about that. The name is Epic. Do I have it? I don't think I have it. Okay, so let me download. I think it's for free. Of course, I cannot do many things when I have this, but that's okay. Yes, I want to use. Excellent. Let me download this. You guys need not download this. Let me also create a desktop shortcut for that. Yep, launch it, please. Perfect. Now I'll use this to write on the screen so that it makes your life easy. Okay, so you see these names, base and readr. This base and readr are called as packages or libraries. Those are called as packages or libraries. What is a library? Usually we know on what is a library, right? Library is collection of books. Library is collection of books basically, right? You all are aware of that. So similar to books, the physical libraries that we know has collection of books. Who has written those books? Someone else has written those books in the past. So I'll try to draw parallels between a book library and the library that we have in the software library. In the book library, you'll have books. In the software library, you'll have code. Code is also called as functions. These books, some author has written these books, right? Here also this code or these lines of code, these functions are written by someone else, some author. And you're making use of this book, reading that, and then trying to implement what you learn. Similarly, you'll make use of the code and functions and accomplish the work that is assigned to you. That's the similarity. Okay. Then you need to, this is software, right? So you need to install these kind of libraries. First step is install. Okay, let me also draw parallels once again here between the libraries that you have here and Microsoft Office. Say you have libraries or packages and you have MS Office. Microsoft Office also you need to install. Here libraries also you need to install. And after installing, when you want to open, you open the application. How do you open the application? You either double click on that. Sorry about that spelling. Let me erase that. Okay, so what you do is you launch the application, you double click on that PowerPoint presentation, or you launch the application. On similar lines, if you want to use a library, you need to invoke the library. How do you install? Here you just double click on the software and it gets installed. Here, how do you install? You use the function, you write this install dot packages, and whichever package you want to install, say you want to install readr, within double quotes you give the name of the package. Within double quotes you give the name of the package and install that. After you install, you want to open that and use it. To open and use, you use this function called as library of readr. Either you put in double quotes or you do not mention in double quotes for this, it still works. But here for installing, you need to mention it in double quotes. Very simple. And when you want to close your application, you just press on this cross mark, right? You press on that cross mark to close any application. In order to close the library, once you're done with the usage of the library, you might want to close it. And if you want to close it, you use another function called detach of package name. Whatever is the package, you say package equal to readr. And our programming is as simple as English language. It is as simple as English language. Like you learn English, you learn R, that's it. But you have to speak with R, the language that R understands. And the good part is R understands English. Slight tailored version of English. Okay, now if I want to load, say CSV file, .csv extension file, you just say import data, click on this readr, and then you can click on browse. For you all, when you click on that option, I mean, when you do a drop down and click on this option for the first time, it will download the library for you. It will download the package. Okay, so let me click on browse and I will search for a file called education. If I do not find that, I will have to search for another file called MEA. No. So let me search star.csv. Some file. I'm just randomly searching for some file. Okay, there's something called as empty cars. I'll just load that. And then you have mileage, cylinder, number of cylinders, displacement, horsepower, so on and so forth. I'll click on import. I'll click on import. Very simple. I try to find where the file is, and then if I click on import, it will load the file for me. But now comes the important part. When I've loaded the file using this option, 3 lines got triggered. 3 lines of functions. One is library of readr. This invokes the library. In order to invoke the library, you have used this. Then this function, in R we call these as functions. This function called read underscore CSV, which is part of readr, which is part of readr package, is triggered. Within the double quotes, you are giving the path on where you have this file along with the name of the file and extension. And what you're doing is you're using an assignment operator. You're using an assignment operator and then you're assigning it to an object. You're assigning it to an object called empty cars. Within R, you call this as object. And another function got triggered, which is view. This view of empty cars displays this file here. Whatever is there inside empty cars would get displayed here. Okay. R is also case sensitive. What do you mean by case sensitive? Let me explain. If I close this, if I type view in small, V in small, okay, and if I say empty cars, I'm typing V in small. It says, hey, could not find the function view. It says error. But if you put V in caps and everything in small, V in caps, then it will show you the data set here. What does that mean? R is case sensitive. You cannot use small when you have to use capital. Very, very important. Okay, then we will discuss a few more things here. You have this empty cars. This is called as object. What is this called as object? This object has 32 observations, meaning 32 rows. Row 1, 2, 3, 4, 5. In that way, you have 32 rows or 32 observations. So rows are also called as, or observations are also called as rows. Rows are also given another name called as records. 1, 2, 3. All these are also called as records. These records are also called as examples. These examples are also called as samples. Rows or records or examples or samples all mean the same. And you have 11 variables. Variables are also called as columns or features. Variables are also called as columns or features. In interviews, they will ask you questions on, after you explain about your project, right? They will explain you on, or they will ask you a question on what is the dimension of your data. When someone asks you on what is the dimension of the data, you have to say rows and columns. That means you have 32 rows and 11 columns. This is what it means. Okay, this is what it means. Then they will ask you describe the feature set. They might ask you on describe your feature set. See, people, just because this is free does not mean we will cut corners. We are going to train you the way we train in our actual class. We keep explaining about the interview questions also, so that our participants start picking up the interview part of the training also. Okay, so your interview preparation already started. Do not assume that this is free session, so these guys won't train us properly. No, we will explain the finest of the thing also to you guys, because that's our strength. Okay, describe the feature set. Now, how many features do you have here? You have 11 features or 11 columns. This is called as column 1 or feature 1. This is feature 2. This is feature 3. In that way, you have all the features. When interviewer asks you on describe the feature set, you should tell them about all the variables that you have used or all the features that you have used in your data and explain about each variable. For example, cylinder. Cylinder is a categorical variable. We had 4-cylinder vehicle, 6-cylinder vehicle, and 8-cylinder vehicle in our data set. This is how you need to explain. And when it comes to gear, we have 3-gear vehicle and 4-gear vehicle. That is what they mean by describe feature set. Collection of all these features is your feature set. Collection of all these features is your feature set. Okay, so you have rows, you have columns, you have these. Now all these are important. And one more thing, we are not expecting people to learn it the moment they watch it. Since you're learning this or hearing to this for the first time, you have to learn multiple times. Remember the swimming example that I've given? Practice. You won't learn swimming in one day. You will learn probably in 1 week or 2 weeks. Python programming or R programming or data science is the same. You need to practice. Without practice, you won't learn. Okay, so watch this video, practice multiple times. All right, now if you want to refer to this column called miles per gallon or mpg, then you can just do one thing, but I'll tell what you need to do. If I want to calculate mean of this, okay, if you want to calculate mean of this, how do you calculate? Given that our language is as simple as English language, you just need to say mean because you want to calculate mean. But remember one more thing, this R is like a small kid. It's like a human being, right? Treat it as a human. It's like a small kid. It doesn't understand until and unless you explain in a detailed manner. If you say find out the mean of mileage, MPG, it throws an error. It says, hey, MPG, I could not find it. Remember, this is a kid. So you have to say, okay, my dear R, you do not understand this. So let me explain. And then you say that go to this data set or object called empty cars. Within this, there is a column called as mileage. Go to that and calculate the mean of this column. That is how you need to explain. In order to explain in such a detailed manner, you'll say, okay, mean of empty cars within this data set, go to this column. To go to this column, you have to type dollar. The moment you type dollar sign, you see the mileage there. Now enter. So object name dollar mileage will refer to this. Empty cars dollar cylinder CYL refers to this, so on and so forth. Now if I enter, yep, what is the average or mean? 20. Given this, it will be very simple and very easy for you all to understand the other functions. If I want median, I'll just say median. And if I want to refer to say cylinder or that's a count, I need not, I should not be doing this, but we can calculate. Let me see. Cylinder. Will it throw an error? Oh yes, certainly it will throw error. It will say, I don't find this, I didn't find it. Then you have to say, okay, don't worry. Go to this data set called empty cars and refer to this. How do you refer to this? You just say dollar cylinder. That's it. Median. It is so simple. But if you feel that, hey, each time do I need to give this dataset name and dollar, don't you think it is complicated? Okay, if you feel it is complicated, then teach your R. Teach this software called R on directly referring to the column names. To teach this R, you have to use a function called attach. If you say attach this data set, attach this object or data set, just run in that way, enter. Now, if you want to refer or if you want to use the function mean and directly this, it will not throw an error. Let's see. One more shortcut, please, please, please look at the screen. One more shortcut. I'm explaining you guys. If you press the up key on your keyboard, up key on the keyboard, it will go to the previous line. If I press the up key on the keyboard again, it will go to the next line, the previous line. If I press the up key, then it will go to the line before that. It will keep doing that, right? So it is very simple. You need not type again. You just press up or down key on the keyboard in this way. And then if I click on enter, it still works. Hey, earlier it threw an error because you didn't teach this baby called R, this kid called R. You once you start teaching that, attach empty cars, then it understands, it learns. The good part is it learns fast. So start treating the R language as a kid. Okay, if you start treating R language as um, you know, as a sophisticated programming language, then you will not learn anything. Remember that. Okay, mode is slightly complicated, so we will not get into that. Uh, just allow me a minute, friends. Just a minute. Just give me a minute. Hey, sorry, friends. Yeah, I was just checking, whether you guys are active or not by muting myself. Sorry. Yep. Um, so let us go here. So there are many data sets, many ways of practicing. Different people have different versions. And one more thing, since I've seen that on the chat, I'm telling you, if you work on Kaggle, which is a competition website, it is good, no doubt about that. But you know what? You will just learn the algorithms. In the real world, when you are interviewed, trust me on this when I say, when you are interviewed, they are going to interview on practical aspects, such as how did you pull the data from a database? You have a database which has data. How did you pull this data into R? How did you trigger your algorithm? How did you write back your results to your database? Which API did you use? For those people who are speaking about Kaggle, this is the answer for you guys, because I've been on the interview panel. Okay. So how do you display the results on a dashboard? Would you use Tableau or Click or Power BI or your own homegrown data visualization tool? Okay. And how do you establish the connection? How did you do this data pipeline? If the data increases at scale, does your model even support that? If you want to deploy your model in production such that it manages the scale of the data, that means if data increases, then how would you deploy? Would you prefer a on cloud solution or would you prefer on premise solution? All these questions will be asked. Industry is becoming intelligent. Okay, as and how many people are getting trained, questions are becoming tougher. These questions you will not be able to answer by any means if you work on Kaggle. If you'll only learn how to apply the algorithms, that's good. I'm not saying it is bad, but that is not sufficient. Okay, let's move on. So you learned about how to calculate mean and how to calculate median. Okay, so let's move on and let us understand about um, let me quickly go there and let me try to open. I'm going to pause my screen and I'm going to load a specific data set for you all. Just give me a minute while not data set, PowerPoint presentation, which I've shown you yesterday, because I want to explain you guys measures of dispersion. Okay, so let me be, let me share my screen once again. There you go. Okay, we'll take a break after 1 hour, friends. We cannot afford to keep taking break because I need to explain you guys many things. I want you all to really learn some beautiful things out of the training. Okay, when you want to analyze your data, the first thing is first moment business decision. Okay, first moment business decision. And as part of first moment business decision, you have mean, median, and mode. When you calculate mean for population, you represent that using Greek letter mu. This is called as mu, Greek letter, because majority of mathematicians were from Greece. That's how it hails. Capital N is for population. For sample, it is small n and it is denoted using X bar. Now we are moving on to the second moment business decision. Second moment business decision. Building on top of what we have learned yesterday, measures of central tendency means if you are CEO of a bank, say you're CEO of State Bank of India, of course you'll not have maybe general manager or of SBI, etc., right? And or let me take an international bank, not this. Let me say HSBC. Say HSBC has its branches in India, Singapore, and USA. The same thing which I've discussed yesterday, I'm repeating for your benefit because maybe internet wasn't good yesterday. The first question which your CEO would ask is, as part of first moment business decision, the first question would be, on an average, what are our sales across these locations? On an average, what are our profits across these locations? On an average, how many products do we sell? Right? On an average would be the first question which any person would ask. Next question is second moment business decision. As part of second moment business decision, as the CEO or as a senior management person, you have to ask questions such as, are the sales varying across these locations? Or are the sales same across these locations? Are the profits varying across these three locations, or are the profits the same across these three locations? That would be the second question that any management person would ask. And hence, these measures are called as second moment business decision. Okay. Say you have data for 6 months, data monthly sales for the last 6 months of India, of Singapore, and USA. Let us compare India and Singapore. You take the last 6 months sales of India and take the average of that, and take last 6 months sales of Singapore and then take the average of that. Say the sales in India for the first month was above average. Second month also it was above average. Third month it was below average. Fourth month it was very close to the mean. Then fifth month, then sixth month, in that way. When it comes to Singapore, maybe the first month sales was very high. Second month sales was very low. Third month it was close to average. Fourth month, then fifth month again it was high. Sixth month again it was very low, right? What is dispersion? Measures of dispersion. Dispersion means variation in your data. Variation in the data. How far away is each point from the average? How far away is each point from the average? How far away is each point from average? How far away is each point from the average is called as measures of dispersion. Here, if you observe, dispersion is less. That means uncertainty is less. However, if you look at this again, how far away is each point from the average is measures of dispersion. How far away is each month sales from average sales? How far is each month sales from average sales? How far is each month sales from average sales? This is dispersion. And look at the fluctuation, look at the dispersion, look at the uncertainty. There is too much of uncertainty in the data, right? Here the uncertainty is very less, it's in this range. Here the uncertainty is very large. Say this is Singapore and this is India. If you all are now data scientists, right? You all are now data scientists. You have stepped into that profession. Here, if someone asks you to predict the sales for next month of HSBC in India versus predict the sales of HSBC in Singapore, in which location would you be more comfortable in predicting? You would obviously be more comfortable with India because the amount of dispersion is less. Here the amount of dispersion is too high. You don't know whether sales will be so high or so less. But here it's in this range. So your prediction will be more accurate with India. With Singapore, prediction won't be accurate. This is the explanation of dispersion. One more thing. Yesterday, I think we have also discussed about one interesting example of US Food and Drug Administration, and my question was, how many fly eggs, sorry, how many fly eggs are permitted in 250 ml of canned citrus juice? Because a few months back, one of my friend was arguing with me saying that, do you know what? Canned juice is very good in quality. Oh, is that so? Then I asked him a question on, okay, do you know how many fly eggs are permitted in 250 ml of canned citrus juice? And do you know what? The drinks such as pulpy orange, it tastes very natural because it will have pulps in it. Those pulps taste very natural. And do you know how these eggs look like? Let me quickly spoil your taste. Okay. Drosophila or fly eggs. Drosophila is like a housefly. Okay. Look at that egg. Egg looks exactly like a pulp. Okay. And US FDA and insects. If I were to go here and show you on a in a canned citrus juice, if you have 5 or more Drosophila or fly eggs per 250 ml, it will be rejected. So the minimum will be 0, average number of fly eggs, maximum that are permitted are 5. If the fly eggs as part of your quality inspection fall in this range, it is accepted. You can consume that. It won't harm you. However, if it's more than 5, your quality department would reject that. Means it's not healthy for you. That's how it is. Okay. So how many of y'all are vegetarians now who have never consumed citrus juice, who has never consumed chocolate? Is there any vegetarian? I'm sure you will say that no. Okay. And that was on a jovial note, guys. But in these kind of interesting scenarios, we use measures of dispersion. Okay. There are 3 measures of dispersion: variance, standard deviation, and range. We shall now take a break. It's almost 3. We will connect back at 3:10. Okay. This is the break time for people who are sleeping. Take a break and the session would start. Session will start at 3:10 p.m. Come back. We will understand this and we will also use R programming on this. Where did that go, man? Okay, here it is. Are you all back from break? Great. So let us continue from where we have left. Um, Now we are going to discuss about variance, standard deviation, and range. Let us first theoretically understand these concepts, and practically we will solve it using R. Okay, practically we'll get to R and we'll do that. So to explain, let me go to Excel sheet. Let me open that. Here we go. Yep. Okay. Say you have weights of people. One person's weight is say 30 kgs, another person's weight is say 40 kgs, third person's weight is 50 kgs. So you have three weights. What is variance? Variance means how far away is each value from the mean. How far away is each value from the mean? Okay, let me do justice. So we will take each value, we will subtract it from average mu. What is average or mu? Let's type here. Mean or average is given as, you just type average, AVERAGE, average of these three numbers and enter. You get 40 kgs. 40 kgs is the average. So here, how far away is each number from the averages? How far away is each number? This number. How far away is each number from the mean? Minus 10 kgs. How far away is each number from average? You got 0 kgs. How far away is each number from the average? This is 10 kgs. Great. Now when you add all these numbers, if you take a summation of all these numbers, you get 0. Does that mean there is no variation? Does this mean that the weights that you're seeing here, these are all the same? No, these are all different. So why would you get 0 then? To solve this, scientists thought that, okay, I think we should not just take a simple summation of all these numbers, but and divide it by n, but we need to actually square them. Now let us see what happens if you square these numbers. So what we need to do is xi minus mu. Don't take just these numbers, but take the square of those numbers. Let us take the square of each number. Square is 100, and the units also will get squared. They become kg square. You have 0, 0 square. Again you have kg square. Here also you have 10 square, which is nothing but 100. Units also get squared. Now if you take the summation of these numbers, when you take summation of all these numbers, you get 200 kgs square. But if you want to calculate variance, what is variance? Variance is add all these numbers divided by the total count, 3 numbers. So 3, 66 kgs square. If you go and tell to your management that, do you know what? The variation among the weights of these people is 66 kgs square. If you say that it is 66 kg square, then it's misleading. They'll say, oh my God, the variation is so less. And how can you say that variation is 66? And also you're saying it is kg square. Are you mad? That is a question that they will ask, right? That is what they will say. Then statisticians again thought, okay, I think somewhere we are going wrong again. How can we fix this? Maybe since we are taking a square, that is the reason units are getting squared. And that could be one reason on why the variance value is showing such a big number because of squaring them. Then they thought, okay, I think we can fix it by taking a square root. We have squared it. So if I take a square root, those gets cancelled. So the issue is solved. Then they thought, all right, let's do this. Let us take square root of variance. And when you take square root of variance, it is called as standard deviation. It is called as standard deviation. And let's simply take square root of this number. Wonderful. Square root of kg square will become kgs. This is the value which you will give to your management. You will say that standard deviation is 8.16 kgs. Variation among the weights, variation or dispersion among the weights is roughly 8.16 kgs. This is the right number. There is also another measure which is called as range. Okay, range is nothing but maximum value minus minimum value. So in order to calculate that, let's first calculate the maximum number. What is the maximum value of this? I can just say it's 50. There are only three, but just to show you the formula, I'm mentioning this. So it's 50 kgs. And then what is the minimum value? Minimum value here is 30 kgs. Now range is nothing but maximum value minus minimum value. What is the max value? 50. What is the minimum value? 30. When I subtract these two, I get range, kgs. Wonderful, right? So let's go back to our mind map and do this quick recap. I'll erase this. Variance gets influenced by or the units. The drawback is that units get squared. How do you fix this problem? You fix this problem by taking square root of variance and then you get back the original units. The units which were squared will go away and you'll get back the original units. And you have range. Range is nothing but maximum value minus minimum value. That's the range. Done. Okay, now I have a riddle. I have a riddle for you all. Let us see who will get it right. And the riddle is as follows. Say you need to cross a river or small water, flow is there. You need to cross from point A to point B. Say the distance is 100 meters or so, very small. And there is a guy who is transporting the people on the boat. You, along with your friend, are standing here. You want to cross. You want to cross this river. And you ask this person on, hey, what is the depth? Because you don't know swimming. Both of you all don't know swimming. So you ask this guy, what is the depth? This person says depth on an average or average depth is 3 feet. And both of you all are say 6 feet. Question to you is, would you cross this river? Would you cross the river? It's on an average 3 feet. Both of you all are there. Both of you all don't know swimming. And both of you all height is 6 feet. Average depth is 3 feet. would you cross from point A to point B? You don't have money, so this guy won't, let you in the boat. Yep. Let me see what your answers are. Hopefully, you will give some meaningful answer. No? Why? Why would you not cross? Because that would be a what kind of a move? That would be a career-ending move. You're afraid that you might die. That's right, friends, because at some point, maybe the depth will be only 1 feet. Somewhere else, the depth might be 10 feet. On an average, it is 3 feet. But somewhere the depth is very steep. Somewhere the depth is not so steep. Right? So if you want to cross, you might die because there might also be 10 feet depth. So you will not cross. A better question would have been, what is the range of the depth? What is the maximum depth and what is the minimum depth? That should have been the right question. Or you can do one thing. You can ask your friend to cross. If your friend successfully crosses, then you cross. That's even interesting answer, right? Okay. So now that we discussed about variance, standard deviation, and range, let us solve it on R. As I've told you, R programming is as simple as English language. It is as simple as English language. So we will do this. If you want to calculate variance, you just say VAR, variance. Say you want to calculate variance of miles per gallon, you just say miles per gallon. There you go. Very simple. If you want standard deviation, it is SD of miles per gallon. There you go. Standard deviation is 6. If you want to calculate the range, it is maximum value of this mileage minus minimum value of mileage. Very simple functions R has. Enter. That's the range. In this way, you can calculate mean, median, variance, standard deviation, range, all of these. Extremely simple. Since you're done with this, we have to discuss about another concept. We will get there. But in this, we discussed about first moment business decision and second moment business decision. We discussed about probability distributions. We discussed about inferential statistics. This is all we discussed. Let me now move on to the next module, the third module. Very simple. This is how you have to learn, friends. Very simple, slow. Yeah. Now, we are in this going to discuss about graphical representation now. Okay, we'll discuss about graphical representation. So let me go back to mind map. As part of exploratory data analysis, you have first moment, second moment, third and fourth moment also is there, but that's not part of a 20-hour program. You also have graphical representation. As part of graphical representation, you have histogram. Even before that, we have a bar plot. You have histogram, and then you have box plot. These three. Just give me quick 1 minute, friends. Just give me quick 1 minute. Just quick 1 minute. All right. Sorry, I told just wait for 2 minutes. Sorry, a few of y'all could not hear that, I believe. That's okay. So we are now going to discuss about graphical representation, bar plot, histogram, and box plot. Okay, three different visualizations. So let us get into the first plot. Question to you all. Okay, let me put a poll. That would be better. I'm putting a poll now. Question to you all. Which there is used measure of dependency. I'm typing the question, guys. Please answer this. Let's see who will get it right. Yep. So yeah, there you go. Please answer that question, everyone. Let us see who will get it right. Oh, wonderful, wonderful. Excellent. Excellent. Majority of you all are getting it right. Very good, guys. Very good. Okay. I think it stabilized, more or less the poll got stabilized. Okay. Wonderful. Yes. The answer is median. The answer is median. Now I'm going to ask another question. Let us see who will get it right. Given that our language is similar to English language, what is the function used to calculate or to plot something that you will see in the answer options? There you go. Yep, I published. Yep, please answer that. Please answer the poll question. Remember, English language. R is very similar to English language. Wonderful. Wonderful, really very good interaction. I really appreciate, friends. Excellent. That is simple bar plot. Absolutely. Great. So you have given me the answer. Look at that. You all have become programmers within no time, friends. So bar plot, if you want the bar plot of, say you want of mileage. So you just say miles per gallon. There you go. Bar plot. A few things are difficult here. You know that if you draw a line around around 30, a horizontal line, there are one, two vehicles whose mileage is crossing 30. And if you draw a line at 10, that I think the minimum mileage is 10. So these kind of basic insights you can draw. However, if you want to draw better insights, you have to use something called as histogram. Histogram of mile. Histogram. This gives a better explanation. What is a better explanation that it gives or better insights? Majority of the vehicles have mileage in between 15 to 20. This is mileage. Very less number of vehicles have the mileage in between 25 to 30. Only two vehicles. Majority of the vehicles have mileage, or 12 vehicles have the mileage in between 15 to 20. You can draw such meaningful insights. right? If you do histogram, Hist- in histogram, you see frequency here. Frequency means number of times. And it creates bins, logical buckets. Your R automatically does that for you. It created a bucket of 10 to 15 mileage, 15 to 20, 20 to 25, 25 to 30, and 30 to 35 mileage. Perfect. Now, that's histogram. Basically, it will just help you understand on how is the data distributed. Now, there's one more thing. Let me go back here. So bar plot is good. Histogram is used to visualize the data distribution. This is also called as frequency plot. This is also called as frequency plot. Now, if you have less data, then it is very easy to identify outliers. That is, you can just, okay, you can say, okay, let me sort in this way. Let me just look at all the mileage. I believe these are the outliers, 33, 32. It's very high in comparison to the other numbers. And mileage 10 is also very less. So that also could be extremely low mileage vehicle. But if I give you 30,000 rows or 30,000 records, huge data set, how would you identify outliers? You'll not be able to just scroll it like this and determine the number of outliers. That would be very complicated. Okay, let me open another data set because I have financial analytics data set also. Let me open some other data. Let me open this data. Okay, just randomly I'm opening some number. So if you look at this, this would be a better data set to load and explain about both histogram also. So let me do this. I'll click on this broomstick. If you click on the broomstick here, it will remove your data set. If I click on this broomstick here, it would remove this plot. If I press Control and L on my keyboard, Control L, alphabet L, and Control together, it will clear the console. I'll also close this. Now, if I want to load the data set, I'll say import the data from reader, click on browse, and then on the desktop, there is financial analytics. Within that, machine learning, neural networks. Let me open this data and then click on import. It imported the data. Now, I'll explain histogram once again on how good it is, right? If I say bar plot of age, right? I have to say data dollar age, dollar. The moment you type dollar, it will give you a shortcut list of all the columns. Select from that, enter. It's very clumsy. Too much of data. Each bar that you're seeing is age of one person. And you have 5,000 bars here. 5,000 bars. It's not clear. It is very unclear. Hence, you can do histogram. Whenever bar plot doesn't make sense, histogram will start making sense. If you want to draw histogram of data dollar age, there you go. So there are very less number of people whose age is in between 20 to 25, right? I think majority of them have age in between 30 to 35, 40 to 45, and 55 to 60, in that way. And less number of people are applying for loan whose age is more than 65. These kind of insights can be drawn. Even from income perspective, you can do that. I'll say bar plot of income. I just press the up key on my keyboard. It's very weird, very weird here. So if I draw a histogram, and if I say I want to draw the histogram for income, there you go. So what is the income for majority of the people? Income is in between maybe 25 to 50, in that range, this one or these two. A lot of them, at least 1,000 of them are in this range. In this way, you can draw meaningful insights. If the income is in thousands of rupees, right? Majority of them have salaries in range of maybe 25,000 to 50,000 rupees. These kind of insights can be drawn. Okay. Now, if you have so much of data, if you want to find outlier, you cannot just eyeball in this way and find an outlier. It is going to be extremely tedious. So how do you find outlier then? How can we find outlier? We can find outlier by doing box plot. If you just do box plot of income, there we go. All these are outliers, right? Yesterday we discussed about box plot. Did we or did we not? That's the question. Let me see. Yeah, did we discuss about box plot, friends? Can you please resort to the chat message? No? Okay, good. So let us discuss about box plot and then come back here. So we know about bar plot, we know about histogram. We'll discuss about box plot. Box plot is a graphical representation of your data. Graphical representation of your data. Lower extreme is called as minimum value. Lower quartile or Q1 is also called as first quartile. From the minimum value to this Q1 or the first quartile, how much data would we have? What do you think? Okay. And you'll have how much data? 1/4 means how much? Friends, 1/4, I'm not speaking about liquor here. Don't tell me 250 ml. Okay, don't tell me that. I'm asking 1/4, how much data would you have? 25% of data. So 25% of the data lies in this range. And box plot is also called as box and whisker plot. Box plot is also called as box and whisker plot. Not whiskey. Not whiskey, it is whisker. For a few of you all, I have to emphasize. Instead of R, if I put Y, you all will be happy. But it's not Y, it is R, whisker. This is called as upper whisker. This is called as lower whisker. Okay. All right. And here you have upper quartile. Upper quartile is called as Q3 or third quartile. And then you have median, which is Q2 or second quartile. Now, from this lower value to third quartile, 3/4 means how much data? If 1/4 is 25%, 3/4 means 3 times of 25, which is 75% of data. If from here until here, if you have 75% of data, and from here until here, if you have 25% of data, then how much data would be there here? You'll have middle 50% of data, which is nothing but Q3 minus Q1. You'll have middle 50% of data. This is called as interquartile range. This is called as interquartile range, which is Q3 minus Q1. You have middle 50% of data. And this line that you see here is called as median. Median is the middle line over there. Now, upper extreme is called as maximum value. Upper extreme is called as maximum value. Any number which falls below this or any number which falls above this are called as outliers. Any number which falls below this or any number which falls above this are called as outliers. Okay. Now, what is the formula to calculate the outliers? It is Q1 minus 1.5 times of interquartile range. Interquartile range. IQR means interquartile range. Okay. 50%, right? If there is any number which is less than this, it is an outlier. And on the upper side, it is Q3 plus 1.5 times of interquartile range. It'll be an outlier. Why 1.5? Why not 1.4 or 1.6? Do you know what? Statisticians, mathematicians have experimented with various numbers for a lot of years. And they found that when they use this number 1.5, it was giving the good results. It was identifying the right outliers. Hence, they stick to this 1.5 rule. And what is box plot used for? Box plot is used to identify outliers in your data. Because when you have huge data, you cannot manually, keep doing this, keep scrolling and then identifying the outliers. You have the minimum value and you have the maximum value. Then you have Q1. Here you have Q3. This is your median. These dotted lines are called as whiskers. These dotted lines are called as whiskers. Just a name. This is called as interquartile range, which is given as Q3 minus Q1. Any number above this or any number below this would classify to be called as outliers, and you have all these outliers. What do you do if you have outliers? You need to analyze. You need to analyze the outliers. Very important. You do not delete, friends. You do not delete your outliers without analyzing. You have to analyze the outliers. Only then you proceed further. Okay. So let me go back to the mind map and write down here. Box plot is also called as, just a minute, sorry. Box plot is also called as box and whisker plot. Box plot is also called as box and whisker plot. Here in the box plot, you will have minimum value, maximum value, first quartile, second quartile, third quartile, and you'll have interquartile range, which is given using Q3 minus Q1. This Q1 is called as first quartile. Q3 is called as third quartile. and Q2 is called as median. Q2 is called as median. Question to you all. Why do we have median and why can't I have mean? Because mean is also a measure of central tendency. Why do we need to have median and why not mean? Can you please answer? Please answer on the chat window. And box plot is used to identify the outliers. Mean is used to, sorry, box plot is used to identify the outliers. Yep. Quickly, let me know on why do we use median and why don't we use mean? Let me see your answers. Exactly. A lot of y'all are getting it right. Thumbs up. Good, great. Very good interaction, friends. Very good. Because mean gets influenced by outliers. Since you're using box plot to identify outliers, you cannot use mean. You need to use a measure which does not get influenced by outliers. That is why we are using median. That's box plot for you all. Bingo. You're bang on target. Very good, friends. Very good interaction. I really appreciate it. Okay. Now what we shall do is, okay, there are two things. We will give you a link and you have to give your attendance. Let me write it here. We shall post a link on chat window for you to provide attendance. Okay. If you have greater than 80% attendance, then you will receive a certificate. You will receive a certificate from our side. Remember this. You will receive a certificate from our side. Okay, next, from tomorrow, we shall have lucky draw. Okay, from tomorrow, you shall have lucky draw. Clear? So please give your attendance. We shall post a link on the chat window. Did we do that? Friends, can you do that? Anyone from our side? Yeah. At 80% attendance, right? So if you have any of your friends who wants to attend, they can. We are going to post the link on the chat window now so that you give your attendance. Just give me a minute. I'll be posting it now. We will be posting the link to give the attendance on the chat window. Enoch from our side would be doing that. Enoch, can you please do that? And next thing is, friends, we posted. The link is posted. There will be something called as sticky attendance on the top. Please give your attendance. If you don't give your attendance, you will not receive a certificate. Hence, please, okay, do this. And the next thing is about our Facebook group. While I mean, people who have already given the attendance, do not worry, you're done. But one more thing, we have a lot of interesting webinars on free R programming coming up, free Python programming coming up. All you need to do for that is go to our Facebook page. Here is a Facebook page. It's there on our website. You can open our website 360digitmg.com. Scroll down. You will have an option to follow us on Facebook. You just go there and you follow us. All you need to do is just follow us. Okay. If you follow us by logging in, then job done. You would receive a lot of interesting messages on free sessions. Link is there on the top. On the top of the chat window, you will see the link. On the top of the chat window, you'll see link. Here is a link for attendance. And for Facebook also we have put. Okay, for Facebook also we have given on the sticky note. Please click on that. Please follow our page. If you follow, there is R programming, free R programming and free Python programming, which would start after these sessions. You would be notified about those. Okay, you will be notified about those. Please don't forget about that. All right, friends. If you have done that, then thank you so much. We will stay in touch. Tomorrow we will connect and we will take this discussion to the next level. Okay. But on you need to be active on social media, friends. That's another thing which interviewers are looking at, whether you are really tech savvy or not, right, Sadvika? So please be active on social media. If you don't have, create an account. People look at whether you're active or not. Yeah, today's attendance, from today onwards we'll consider the attendance. From today onwards we will consider the attendance. Okay. All right, friends, please practice, practice, practice and practice. Job will be yours. Future will be yours. Okay. Job and future will be yours. Please focus on practice. You watch the recorded video once again on our YouTube channel. We will post that. And then if you still have doubts, you can ask and we would certainly answer those questions. Thank you all. Over and out. Bye for now.